Title: GABInsight, Exploring Gender Activity Binding Bias in Vision Language Models. Abstract: This paper introduces the concept of gender activity binding (GAB) bias in vision language models (VLMs), which refers to the undesirable association of a factor with a gender according to the model. The authors have created a dataset known as the Gender Activity Binding (GAB) dataset, comprising AI-generated images depicting various activities performed by men or women in different contexts, each accompanied by a descriptive caption. They benchmark the performance of 12 renowned multimodal foundation models and assess their performance in terms of text-to-image retrieval, image-to-text retrieval, and recognizing activities on the GAB dataset. The results indicate that VLMs experience an average performance decline of about 13.2% when confronted with gender activity binding bias. Introduction. The paper discusses the potential biases in vision language models, VLMs, particularly focusing on the gender activity binding (GAB) bias. This bias arises due to ingrained gender stereotypes in the model or other types of sample selection biases. The authors aim to explore this bias in retrieval tasks and assess the performance of VLMs in identifying the performer of an activity based on the context provided. Dataset creation. The GAB dataset is created using DALL-E to generate images depicting various activities performed by men or women in different contexts. The activities included in the GAB dataset are sourced from various places to encapsulate societal gender stereotypes and other activities that are statistically biased towards a specific gender, as observed in the LAION 400M dataset. Performance benchmark. The authors benchmark the performance of 12 renowned multimodal foundation models and assess their performance in terms of text-to-image retrieval, image-to-text retrieval, and recognizing activities on the GAB dataset. Specifically, in the image-to-text retrieval task, they observed that while an unexpected gender is doing a stereotypically biased activity, the average performance of VLMs declined by approximately 33.2% due to the presence of the expected gender in the scene. Moreover, most VLMs undergo an average accuracy reduction of approximately 13.2% when encountering gender activity binding bias. On the other hand, in the text-to-image retrieval task, most VLMs achieve an accuracy of approximately 50%, indicating that their performance is nearly random, and they failed to recognize the performer of the activity based on the text. Additional experiments. The authors carry out supplementary experiments to investigate the binding bias in VLMs' capability to comprehend activities and the bias present in their text encoders. They delve into the insights that can be derived about how VLMs internalize this bias and its impact on the shared embedding space of VLMs. Related work. The paper discusses previous works related to vision language models and gender activity binding bias. It highlights that VLMs have many categories of biases, especially gender-related ones, and that previous studies have measured gender bias in VLMs by comparing the mask token prediction probabilities of factual and counterfactual samples. Conclusion. The study is the first to delve into the origins of the association between genders and activities in vision language models by conducting a thorough analysis both image-to-text and text-to-image retrieval accuracy of VLMs. It encompasses not only straightforward scenarios involving single individuals, where VLMs demonstrate high accuracy for both genders, but also more complex situations with individuals of different genders. This comprehensive approach allows us to isolate the impact of the complexity of the scenario on performance decline and more accurately measure the gender activity binding bias. The research paper introduces the concept of gender activity binding bias in vision language models, VLMs, which refers to the tendency of these models to associate certain activities with specific genders. This bias is problematic as it can lead to errors in image and text retrieval tasks, particularly when the activity is performed by an unexpected gender. The paper proposes a novel dataset, called the Gender Activity Binding (GAB) dataset, to evaluate VLMs against this bias. The dataset consists of AI-generated images that illustrate a variety of activities with potential subjects of both genders. The images are divided into 4 distinct groups, each representing different scenarios: expected gender performing the activity with the other gender present, unexpected gender performing the activity with the other gender present, expected gender performing the activity alone, and unexpected gender performing the activity alone. The dataset creation process involves three methods to identify biased activities: using GPT-4 to request stereotypical activities associated with men or women, compiling a list of everyday activities using GPT-4, and extracting verb-object pairs from the LAION400M dataset. The activities are then used to generate prompts for image generation, which are enhanced using a large language model, LLM, to ensure diversity and quality. The paper also introduces a metric to quantify the bias, called the bias score, which is calculated as the log ratio of the probabilities of the mask token being man or woman, given the sentence. The bias score is used to select biased activities and evaluate the performance of VLMs. The GAB dataset is designed to facilitate the evaluation of VLMs against the gender activity binding bias and their ability to bind and recognize activities. The dataset structure allows for the definition of different retrieval tasks, which can be used to assess the model's strengths and weaknesses in handling gender activity associations. The paper highlights the importance of addressing the gender activity binding bias in VLMs, as it can have significant implications for real-world applications. The proposed dataset and metric provide a valuable tool for researchers to evaluate and improve the performance of VLMs in this regard. The research paper discusses the development of a novel dataset, GAB, to evaluate vision language models, VLMs, in text-to-image and image-to-text retrieval tasks. The dataset is designed to assess the performance of VLMs in recognizing gender activity binding bias and activity recognition. The paper also proposes a methodology for generating diverse and high-quality images using a combination of automated metrics and human evaluation. The image generation process involves clustering and sampling prompts to enforce diversity and then using DALL-E3 to generate images. The generated images are filtered using a combination of automated metrics, including Frechet inception distance, FID, and structural similarity index, SSIM, and human evaluation to ensure high-quality, relevant, and diverse images. The paper then presents the results of experiments designed to evaluate the performance of 12 VLMs on the GAB dataset. The experiments involved text-to-image and image-to-text retrieval tasks, as well as activity recognition. The results show that most VLMs experience a significant drop in performance when the scene includes two genders, with an average performance decline of approximately 33.2%. Additionally, the results indicate that the model's performance is affected by gender activity binding bias, with an average accuracy reduction of approximately 13.2% when the action is performed by an individual of the unexpected gender. The paper also evaluates the bias in the text encoder of different VLMs and finds that the models demonstrate satisfactory performance in the image-to-text retrieval task on both image scenarios of U1 and E1. Indicating that the gender bias adversely affects the performance of the models only when there is more than one individual in the image. The results highlight the importance of considering gender activity binding bias in the development and evaluation of VLMs. The methodology employed in the paper involves a combination of automated metrics and human evaluation to ensure high-quality, relevant, and diverse images. The use of FID and SSIM metrics to evaluate image quality and diversity is a key aspect of the methodology. The paper also employs a caption template to evaluate the performance of VLMs in the image-to-text retrieval task. The results of the experiments are presented in several figures, including Figure 2, which shows the average retrieval accuracy of VLMs on the image-to-text retrieval task across various scenarios. Figure 3 shows the average retrieval accuracy of VLMs on the image-to-text retrieval task on E1 and U1 category of images on stereotypical activities. The results highlight the importance of considering gender activity binding bias in the development and evaluation of VLMs. The study investigates the gender activity binding bias in vision language models, VLMs, which refers to the tendency of these models to associate certain activities with specific genders. The researchers created a unique dataset, GAB, consisting of approximately 5,500 images, to assess the performance of various VLMs in image-to-text and text-to-image retrieval tasks. The results show that VLMs exhibit a significant bias towards expected gender activity pairs, with the majority of activities exhibiting a bias towards the expected gender. The study also evaluates the bias of the text encoder in VLMs, finding that the majority of activities exhibit a bias towards the expected gender. The results are presented in Table 1, which shows the proportion of activities where substituting the gender-neutral term, person, with the expected gender reference results in a higher matching score in the embedding space. The researchers also investigate the performance of VLMs in text-to-image retrieval tasks, finding that the models achieve an accuracy of approximately 50%, indicating that their performance is nearly random in this task. This suggests that the gender activity binding bias is primarily absorbed by the text encoder rather than the image encoder in VLMs. The study discusses the limitations of the current work, including the lack of access to the training sets of the models, which prevents a direct investigation of the source of bias in the training data. The researchers plan to address this limitation in future work by examining the sources of bias in publicly available training datasets for VLMs. The study concludes that the gender activity binding bias is a significant yet overlooked bias in VLMs, and that the experimental approaches described can be extended to other social biases, such as race and age. The researchers also suggest that the ability of VLMs to comprehend activities and perform compositional reasoning in complex scenes are other crucial factors contributing to the gender activity binding bias that could be investigated in future research. The study provides a comprehensive analysis of the gender activity binding bias in VLMs, highlighting the need for further research in this area to mitigate this bias and improve the performance of VLMs in various tasks. The results of this study have significant implications for the development of fair and unbiased VLMs that can accurately represent and understand the complexities of human activities and behaviors. This research paper explores the issue of gender activity binding bias in vision language models, VLMs. The authors identified three categories of biased activities: stereotypical, everyday, and LAION 400M. They provide a comprehensive report of each category in Tables 2, 3, and 4, detailing the expected subject and amount of data in each setting. The authors experiment with various image generation models, including diffusion models and DALL-E3, to generate images that represent the intended activity. They choose DALL-E3 as their final image generation solution due to its improved quality of compositional generation. To mitigate bias in VLMs, the authors discuss several approaches, including orthogonal projection, additive residual image representations, learnable prompts, and fair dataset creation. However, each method has its limitations, such as stripping away useful nuances, requiring extensive and diverse data, or introducing new biases. The authors evaluate the performance of VLMs on image-to-text retrieval and text-to-image retrieval tasks. The results, presented in Figures 5, 6, and 7, show a performance drop between scenarios for each model. The models exhibit an average accuracy of approximately 90% in identifying the correct image that represents the gender of the individual performing the activity. The authors also discuss the limitations of their approach, including the potential for overfitting to adversarial objectives and the risk of introducing new biases. They highlight the need for further research to develop more effective methods for mitigating bias in VLMs. The paper concludes by emphasizing the importance of addressing bias in VLMs to ensure fairness and accuracy in downstream applications. The author's work contributes to the ongoing effort to develop more robust and fair VLMs. Key terms and concepts: vision language models, VLMs, gender activity binding bias, stereotypical activities, everyday activities, LAION 400M dataset, image generation models, diffusion models, DALL-E3, bias mitigation approaches, orthogonal projection, additive residual image representations, learnable prompts, fair dataset creation, image-to-text retrieval, text-to-image retrieval, methodologies, experimentation with image generation models, evaluation of VLMs on image-to-text retrieval and text-to-image retrieval tasks, analysis of results using accuracy metrics. Significant findings: VLMs exhibit bias in representing gender activity binding. Different image generation models have varying levels of success in representing the intended activity. Bias mitigation approaches have limitations and require further research. Important arguments. Addressing bias in VLMs is crucial for fairness and accuracy in downstream applications. Further research is needed to develop more effective methods for mitigating bias in VLMs. The research investigates the bias in binding gender with certain activities in vision language models, VLMs. To gauge the model's understanding of activities, the authors collect several activities performed in the same environment as the reference activity for each activity in the GAB dataset using GPT-4. For each image in the GAB dataset, a caption is created from the reference and associated collected activities, arranged based on their matching score to the image. The results, presented in tables 57, show that VLMs can recognize the performed activity in image-to-text retrieval tasks to some extent. The authors report metrics such as mean reciprocal rank, MRR, recall at 1, and recall at 3 for the true caption, reference activity, in tables 57. The results indicate that the models can retrieve the correct activity from a list of activities, with varying degrees of success. For example, in Table 5, the alt-clip model achieves an MRR of 0.464 and recall at 1 of 0.311 for one gender presence, while the EVA02L14 model achieves an MRR of 0.565 and recall at 1 of 0.391 for one gender presence. The authors also investigate the model's ability to retrieve the correct activity from among those gathered from GPT-4 for gender-biased everyday activities, Table 6, and gender-biased activities from LAION400M, Table 7. The results show that the models perform better on gender-biased activities from LAION400M, with the EVA02L14 model achieving an MRR of 0.696 and recall at 1 of 0.592 for one gender presence. The findings suggest that VLMs can recognize activities in image-to-text retrieval tasks, but the performance varies across models and datasets. The results also highlight the importance of considering the context in which activities are performed, as the model's performance improves when the activities are gathered from the same environment. The study's limitations include the reliance on a specific dataset and the need for further investigation into the model's ability to recognize activities in more diverse contexts. Future work could explore the use of more diverse datasets and the development of more robust models that can recognize activities in a wide range of contexts.